Hi friends, in this video I am going to explain about the introduction of frequency response analysis. Clear? So actually why we are going for the frequency response analysis, what is the main advantage means, actually there are so many advantages when compared to time response analysis. Okay, so instead of time response analysis we are going for the frequency response analysis because there are some few advantages are available in the frequency response analysis. Clear? So before I'm going to explain about the advantages and the disadvantages of a frequency response analysis, first I'm going to introduce the frequency response analysis introduction. Okay, so here actually what is the procedure we need to follow whenever we are going to study about the frequency response analysis means, so when we are talking about the frequency response analysis, the input must be sinusoidal function. Okay, for example, just see here, so for frequency response analysis input must be sinusoidal. That is what, for example, the sinusoidal function or the input sinusoidal function in the form of what, r of t is equal to a into sine omega t. Okay, so r of t is the input we are applying to the system, and this function is always in terms of sinusoidal. That's why a into sine omega t. So this is the sinusoidal input. Clear? And what is the output we are expecting from the system when we are applying the frequency response means, so output must be in the form of what, so c of t is equal to b into sine omega t plus pi. Clear? So here b is the magnitude of a system and here phi is the angle of a system. So from this total topic frequency response analysis, whatever the system he given sinusoidal function, so finally we are going to get the total output must be in the form of magnitude and angle. Clear? So for that, so the with the help of this I can define the frequency response is that simply we can say that, so the definition of frequency response is the magnitude and the phase relationship between the sinusoidal input and the steady state output of a system is termed as the frequency response. It means what? So we are going to including the input sinusoidal function, and I am going to talk about the steady state output. So between this sinusoidal input and the steady state output, we are going to concentrating only on the magnitude and the phase angle. Clear? So that's why I am defining the frequency response is that the magnitude and the phase relationship between the sinusoidal input and the steady state output of a system is called as the frequency response. Clear? So this is the definition of frequency response. But whenever we are going to study about the, whenever we are going to apply the frequency, whenever we are going to study the frequency response, so actually what is the procedure we need to follow? Clear? So that's why just see here. So this is a very important point, just remember this one. So the frequency response test, for example I am going to applying the frequency, or I am going to study about the frequency response of that particular system, then I need to follow, or we need to follow the frequency response test on any system is normally performed by keeping the amplitude A is fixed and determine the remaining parameter, that is what, determine the b and phi for a sinusoidal, for a suitable range of frequencies. It means what, whatever the system, whatever the input we are taking and whatever the output we are getting, so between these two just compare, concentrate on only this input and output. Just see here, the frequency response test on any system, it means whenever we are going to apply this one on any system, the frequency response test on any system is normally performed by keeping the amplitude A is fixed and determine the value of B and pi for a suitable range of frequencies. So this is the actual procedure we need to follow to get the frequency response. Clear? So for example, how we are going to convert, or how we are going to convert the given sinusoidal input into the output means, for example input z is equal to 10 plus j into 20. For example, this is the input. For example, now I want to calculate the magnitude of this input, and also I want to calculate the value of angle phi. So that's why to calculate the magnitude, mod z is equal to root of 10 square plus 20 square. It means the value of z is equal to what? 10 plus j into 20. It means z is equal to r plus j into x. So that's why to calculate the value of mod z, so mod z is equal to under root 10 square plus 20 square. By solving this, you will get the magnitude. And after that, again I need to find what? Phase angle. So phase angle phi is equal to tan inverse of 20 divided by 10. So that is what? Tan inverse of imaginary by real. So tan inverse of 20 divided by 10, that is equal to tan inverse of 2, that is equal to 5. By getting the value, sorry, by solving this value, you will get the value of what? Phase angle. So after getting the phase angle and after getting the magnitude, just write down the output in the form of C of t is equal to m into angle phi. Clear? So this is the simple procedure we need to follow whenever we are going to study about the frequency response. Okay, so in the next class I'm going to discuss about the advantages and the disadvantages of a frequency response analysis. Clear? Thank you so much.